What is up, ladies and gentlemen? Welcome to the second series of Code with Joel. Today we're going to be talking about data visualization. Now this is going to be a really jam-packed session, so we're going to get right into it. We're going to be doing economic and financial charting. We're going to kind of scratch the surface and just explore a bunch of different things that can be done in R, and I'm just going to expose you to a bunch of different techniques. And yeah, I mean, if you have any questions, like specifically on how you should approach a specific visualization problem, definitely let me know. But the thought is to introduce you to a bunch of different packages and the capabilities of those packages. I'm also going to be using the wbstats package for our economic data. It's like an interface to the World Bank's data sets. And we're also going to be using quantmod to pull in financial, like stock data from, the internet. I think it uses Yahoo Finance or Google or Oanda and some other providers that you can connect to pull like open, high, low, close tick data. So because this is like a data visualization course and not a data wrangling course, I've done some setup over here already. I've kind of pulled in and just like wrangled the data that we will be needing. Go ahead and pause the video now, just get all of this down. I'll explain what's going on when you're done, and we can go from there. Just to explain the packages we have here. So if you don't have any of these packages after like running them, just do install packages and then followed by the package name, and then you just run it. You only need to do this once, otherwise just go ahead and just run library on all of these. So we have tidyverse, wbstats, data table, gg themes, plotly, psych, highcharter, quantmod, and TTR. If you're curious about what TTR stands for, it stands for Technical Trading Rules. So, alright, so I'm using the WB stats package, and the way their syntax works is they have a function called WB, and you would just use or reference one of their series name or indicator IDs or tickers or whatever you want to call them to then pull in the data for that respective series name or indicator ID. The way you find out what ID to use in the first place is you can use this WB search function. Look for something like population, for example. When you run that, you'll just get a bunch of indicator IDs, and the second column just has the description of the indicator. So, I mean, this is a great way to pull in data from the World Bank. If you really wanted, you could loop through, I guess, every single indicator ID. Use these as like chart titles in a very short period of or short amount of code, and you can pull. Wonder if you do like just like a apostrophe, what would happen? So yeah, it looks like that's like that. You can pull every single series using WB search with yeah. So. Anyways, I'm going to go ahead and run all of this data. The first thing we're going to do is a line chart, then we're going to do a histogram, then a scatter plot. From there, we're going to make our scatter plot interactive, and we're also going to add an animation element to our scatter plot. So I've pulled in each one of these individually, and I have also kind of grouped them all together into a single data frame. Just so we can see what that grouped data frame looks like, we have each one of the indicators in each kind of column for themselves. We have ISO 3C, which is like a 3-digit country code, which we will use to do a geographic plot. And then from there, after the geographic plot, we'll do some of the financial open, high, low, close plotting. So you have some other like data points we don't need to get into. The first thing I want to do is look at GDP for the US. So what I'll just do is we'll do our line chart. GDP time series. Alright, so we're going to do a time series line chart. So the way these plots work And maybe what I'll do, just because this will become a little relevant, is just create a line data object where I take GDP and filter this ISO 3C column by USA. Alright, feel free to use whatever country you like. In this instance, I'm just using USA. So the way ggplot works is you first specify, you call the ggplot function. This is the ggplot function. So you would then specify your data. So you need to use some sort of data in your chart. The way you do that is data equals line data. So from there, you would do like a geometric object, like your geom. So you have some options. You have box plots, histograms, lines, violins, all sorts of things. In this case, we're going to do a geom line, and within that function, you say AES. So AES is just like your aesthetics for your ggplot, and X is going to be equal to our date column. So X equals date, Y equals value. So if I give this a quick run, you'll see we already have like a line chart. So I mean, this is a line chart, but we can't use it. I mean, the whole point of visualization is to extract meaning from your data to maybe gain some information you wouldn't have been able to find out otherwise, or even communicate some findings of your data analysis. So graphs are a great way to do it, but this graph is not, because it's not very descriptive. So let's add some labels. The way we add labels is with the labs function. So labs title equals maybe GDP per capita and current USD. So that just corresponds with the denomination of the currency over time. And we can also change our x-axis. So you can see everything is lowercase. So we have a date and a value. Let's just call it date on the x-axis. Our y-axis, or y, will be equals to, let's just say, current USD, just current dollars. So if I give that a quick run, and you can see now we have a title. We have x-axis that's kind of in proper form, and we've totally renamed our y-axis. So how else can we improve this? Well, also within labs, there's this subtitle argument we can add in. So within this, maybe I'll say first just write the paste function, which just kind of concatenates a bunch of different strings. So you would do from and comma. We can say min, which is a base R function to find the minimum of a number in a vector. We would do line data $date. So if we just run that individually, you can see min date is 1960. So this data set goes as far back as 1960, which we kind of saw in our actual chart. Then we'll just say 2, and then I'll just put in max line data $date. So if I give that a quick run after just doing a sep argument. So what sep is just like within paste, you just say, hey, I want you to separate each one of these components with this. So the separation is a blank. If you run all of that, you can see from 1960 to 2016. So maybe the ticks weren't as explicit, so this is explicitly calling it out. It just adds another dimension of information to the chart itself. So instead of just one line, we all of a sudden have a lot more information. But we can still make this look cooler. This is just a boring, black and white chart. Let's just add some, pizzazz to the chart. The way we do that, I mean, there are a couple things. So first, we can use the GG themes package. And by the way, in R, if you type in the package name, as I have done here, followed by 2 colons, you're explicitly calling out the package name itself. So in doing so, I mean, you avoid like conflicts. Maybe 2 packages have the same function. By the way, there are about 10,000 packages in R that can be used, even more than that, I would assume. So, I mean, if you ever are afraid of any conflicting issues, you're using tons of packages, for example, just call out the package explicitly. So what you can do over here is, and maybe I'll call out packages explicitly in future videos, just so you know exactly which package things are coming from. So within GG themes, I mean, just to take a quick step back, you can see GG themes is called the package. This package contains extra themes, blah blah blah. Long story short, it's just a extension to ggplot. And if I write theme, I can get like all these different pre-built chart themes. So if I use theme solarize, for example, the chart's going to look like this. It's like kind of like it says a solarized theme. But since this is economic data, I did notice there's economist theme, so maybe I'll use theme economist white for this economist data, so economic data. So there you go. I mean, it's kind of looking a lot better. The title is bold, and the X and Y axis are a little more visible. What we could do is we could increase the width of our line. We can even change the color of our line. So there are a lot of ways we can do that. Let's first, I'll show you the first approach. Let me just do that real quick. So color equals red, for example, if you want your chart to be red. So you can see I put that outside of AES, and now I have a red line. And I mean, you can do things like dark blue, for example, dark blue, or whatever. I mean, you can just play around with that. What you can also do, and my kind of preferred approach, is to use this kind of hex color picker in Google. So if you just go to Google and type in hex color picker, just as I have done over here, you can just kind of drag your little mouse icon over here and use this kind of scroller to pick a color out. And I mean, there is a bit of a art as well as to getting these colors. But what you can do is you can use hex codes directly instead of just like saying RED, just spelling out red. You do that. So I don't want to spend a whole lot of time, figuring out which color to use. So I'll just kind of leave it at that. It doesn't look bad. So I think I'll do that and say my size is equal to 1. So if I just run that really quick, see the width of the line is a little bigger. If I just make this like 3, for example, it will probably look ridiculous, but I just want to show you that's what you can do. You would never want to do that. Can't imagine any reason to do that. So I mean, this is just wide enough to the point where it kind of stands out. It's not bad. So one other thing, the reason I kind of broke out a new data data object over here called line data was I wanted to show you something. So I can actually take this argument within ggplot called data equals line data. I'm just going to cut it, just cut, and I'm going to paste it over here under my geom line argument. Don't forget a comma separated, don't forget a comma separate your arguments within your ggplot geoms as well. So if I run this, it's going to do the same exact thing. But now let's say I want to add another line. I also want to add, let's just use this ISO code, which is Aruba, into a new line data object over here called ABW. That's my filter, ABW. I'll call this line data 2, and if I just run line data 2 and just show you what it looks like, you can see I have GDP 18 observations for Aruba's GDP per capita. So the way I would add that line to this plot is just by throwing it down over here and just say line data 2. So if I run all of this together, maybe let's make this red since it's a different line. Just run that, And now you can see I actually have a line of Aruba as well as a US. Now we are missing a couple things. I mean, now the subtitle is kind of irrelevant because, yes, US starts from 1960 to 2016, but Aruba doesn't, so maybe this isn't the right subtitle to use. There's some other things we could also modify with this chart, for example, the number of tick intervals, or adding a legend to indicate which line corresponds with which country. Just for brevity, we'll go over some labeling in future visualizations. Just for brevity, I'm gonna jump into the next visualization. But I mean, I think right here we have a pretty good looking chart. I'm just gonna comment this out. I just wanted to show you what that looks like and show you what our final U.S. GDP per capita over time looks like. A simple line chart that takes like some date object, or in this instance a year object. It should really say year because these aren't like full-blown dates. These are just years. I'll just rename that, just say year. I have 1960, so there you go. So we'll move into a histogram. So histogram, they're really good for just trying to understand the shape of your data and the distribution of your data, to check whether it's normally distributed or like skewed in any way, or if there's like any bimodality going on or whatever have you. So it's the same setup. It's the same setup as before, but the only difference is we have geom histogram. You do want to specify your data. And by the way, if you're wondering which I prefer, should you put data up here or should you put data down here? I usually put data down here. That way you have control over adding additional layers should you choose to do so. That's just one approach you could take. So in this instance, I'm going to use a life expectancy data object. So I'll say data equals life expectancy, and in this instance I'm going to specify my aesthetics. My x equals my value, and I don't need to do anything else to the y-axis because it just takes care of that for me. So how can we make this better? I mean, the title might be a good place to start. I mean, the colors are also another place to start. There are just some usual things that you can do to make your chart look better. And before anything, I would suggest having a title in your chart is the most important, because without a title, people won't know what it is exactly they're looking at. Birth, so I'm just going to call it the global distribution of life expectancy of birth. I'm going to say my x is now, instead of value down here, I'm just going to say x is equal to life expectancy. So maybe say years or age, and y I'll just change to frequency. Frequency, not frequency. I give that a quick run. Whoops, and you'll see I spelled labs wrong, so it's labs, not lab. So there's this interesting thing here that says stat using bins 30. What bins are in this histogram? Bins are the number of columns. So if you want to control that, for example, right outside of AES, you could just do bins equals, let's just be extreme and say 5, for example, so we should expect to only see 5 columns. But in that case, we're really kind of compressing our histogram. We don't really want to do that. Let's just do 25. There are some rules of thumb you can use. I think some of the rules are like Doan's rule and whatever. There are tons of different rules you can use to determine the optimal number of bins. You can take the log of the number of rows and multiply that by 3 or whatever, but I mean, ultimately the point of the visualization is to tell a story. and to discern some better understanding from this chart. So what am I understanding from this chart? So I'm looking at this and I'm seeing that there's some negative skewness, and skewness just measures the asymmetry between your tail. So you can see my left tail is very fat, and it goes out kind of really long. It's a longer tail than this right tail, so that's just like indicative of skewness. So when your right tail is shorter than your left tail, that means your skewness is negative. But before we even get into you know, any of that, let's just do some more aesthetic related work. So we'll just maybe make the color equal to something else. So the color corresponds with the you know, the outline. Sorry, the color of the outline. Let's just change that. This looks fine to me. And if you do fill, so the fill color of the chart will be the inner fill. So maybe you do like a two-tone, like dark blue, light blue theme. I think that looks pretty okay. Just do one of those, paste that in, see what this looks like now. Yeah, there we go. I think this looks a lot cleaner. And I don't know if you noticed, but there's actually some observations here on the very left of the tail. So it seems like the tail was a little more long than we'd initially thought, because when we just ran this to begin with, there's no border around the actual color. I just commented out the border color so you can see this. There's no tail over here, but in fact we do have data that indicates there are some observations over here on the very left of the tail. So I guess in that regard it is advantageous to have a bordered color, and this is exactly how colors can make your charts more accurate, and how they can also make your charts look a little cooler. Alright, so what else can we do here? So I guess some things I can show you. You can just create an object called plot, and I mean, feel free to play around with these colors. I'm not spending so much time on getting the colors right. I usually do like these two tones. It's like a similar, like one's a dark blue, one's a light blue. You can do dark green, light green. I don't know, if you find a really cool color scheme or some theme that goes really well with a histogram or whatever, drop them down in the comments below. I'll give you a shout out in a future video, and we'll take a look at what your chart ends up looking like. But what I wanted to show you was saving a plot object, or an object to a ggplot object rather. So you can see I had this assignment operator. I said plot is just create a ggplot object and store it under plot. So that's what I did over there. You can now see if I type in plot and just run it, kind of comes out down below here. I can also go down to my console and type in plot, and it'll come up on the right hand side over here on I guess I didn't run it yet, but on my viewer. Looks like my camera is kind of in the way there. Whoa, don't want to do that. Want to do that. So you can see it almost it's over there on the viewer, but I'm just going to move my camera back and just exit out of that. We'll use the viewer for the most part. Or we will need to use a viewer in certain instances, but in this instance we can just use a markdown just fine. So now let's get into the what's it called? The scatter plot. So the scatter plot, we're gonna do a scatter plot with interactive and animated features. So I'll just do one of those. So, all right. So now we're going to use our df object that we created earlier. Let's just take a quick look at it again. So to begin with, we have every single country and our variables are in the kind of each individual column. So we have GDP per capita, life expectancy, and population. So if you watched my data wrangling course, you will know that working with spaces in your columns are problematic. We're going to kind of just work around those because it will turn out these will show up in our chart pretty nicely. So I'm going to do that. But let's create a scatter plot to begin with ggplot, and then we'll get into Plotly, which is like a interactive visualization tool, and then we'll use Plotly to create an animation. So just to begin with, let's say data equals df, and let's just do this. Actually, let's actually just keep it just like that to begin with. I want to show you the Preston curve, which is like the relationship between GDP per capita and life expectancy. And if we do it at every single observation, it'll become pretty evident. So I'm going to do geom point, which is basically just a scatter plot, and you need to specify your x-axis. Make sure to do this with your backticks, just because we have spaces over here. So we'll do GDP per capita, and then our y is equal to, and don't forget AES, it's important. Know your aesthetics. I'll just kind of clean this up over here. And y is equal to our life expectancy, and spelling does matter, so make sure you're just calling out the exact name of the column. So I'll show you what this looks like, and it's just a pretty big amorphous blob of data points over here, but you can actually see the Preston curve. So the Preston curve is just a relationship between, as we have here, GDP per capita and life expectancy. But what this kind of tells us is, like, as income per capita rises, there is a corresponding effect on the life expectancy, kind of right around here. Curves, but there is a cap. So that cap is essentially, just indicative of the fact that we are, biological organisms, right? So, I mean, we can't live forever. Maybe as technology advances, the frontier of the Preston curve will move up, but there's a kind of ceiling to life expectancy, although there is some relationship between having more money, as you can see, and the longevity of a population. So that could be because you can afford healthier food or better access to healthcare and so forth. So those might be some reasons why. We won't go too much into the economics as much as the visualization. So how can we, make the visualization better? Let's start off with our labs. Our title will be equal to our relationship. So we'll just say title is relationship between GDP per capita and life expectancy. So do that, and what I'll also do over here is I'll just throw in a filter, so our date, which we work in 2015 only for now, and then we'll get to some animated features. And don't forget two equal signs when you're doing the filter command. So now we've just kind of subsetted that large data set into just 1 year. So I'm going to introduce you to some more packages. We'll use viridis. So within viridis, there's this scale color viridis, which will come into handy later. Actually, it's a little early to do that, but I'll just keep it there for now. What we can do is just create color outside of AES equals our population. I'll give this a quick run. Throw that in here. Get rid of this comma. So there we go. You have to put color within AES. That was my bad. And then also we can make the size of our chart, each point, a function of the size of the population. So just like that, and give that a run. So you can see now the points are sized based on the size of the population, and the color scale is as well. If I were to get rid of this scale color viridis, you would see that the default color scale is just like dark blue to light blue. This looks cool too. I just wanted to show you that you have this viridis package that is just like an extension to like some continuous variables where you can add that color scale. And there are also some options, like you can do magma, for example, which just gives like I think like a dark to red, or yeah, like a dark, like a black, purple, red, yellow kind of scheme. So I mean, there are a bunch of different options. I think Inferno is one of them. You can check out Viridis options on Google, and you should be able to find a list of every single one of those. I'll just use the default for now, because what I really want to show you is how to make this interactive. So the way we make this interactive is with the Plotly package. So Plotly. What I'll do is I'll just copy this over here, and I'll create a object called P. You can call it whatever you want. I'll just call it P, just as a matter of convention. And now I've saved this kind of ggplot object as P. You can see in my global environment I have this P over here. So if I do ggplotly, which is right over here, I'll just do plotly, ggplotly P. You can see it's kind of loading, but now I have this really cool interactive visualization. There are some ways we can improve it for sure. For one, looks like the font changed. It's like a Calibri or something. I want to go back to Arial. I would usually like using Arial for most things. What's cool about this is you can kind of zoom in, double click to zoom out, and actually, I mean, you can do a box select, and for like application development, for example, you can use like this box select to like return in real time like the averages as you hover your box select over the points and so forth. So it is a little convenient and nice. So you can download images and so forth. So a lot of things you can play around with. But let's first get our font sizes. So our text will all be the same font. Element text. So this is basically the same way you would create a custom theme is by using the theme argument and then calling out each one of these individual components. As I'm doing here, I'm just saying find every single text element within your ggplot object and then just make it Arial. So if I just run all of that, you can see everything is Arial now. So the next thing, you probably have noticed this by now, is the tooltip, the hover text. It is in really bad shape. I mean, like, it's repeating population. It has maintained and kept those like backticks. We want to get rid of all of that. So let's do a manual override of our text. So we can add in text within AES, and we'll use paste. And another thing we want to know is like what country this point is, for example. Like, I don't know, they seem to have like a high GDP per capita and population, but maybe, yeah, so I mean we need to know that kind of stuff. So we can type in country and then just call out the country column, which, if you remember, our country column is over here in DF. So I'll just do country, and the way you do a line break in these is just with BR tag. So I'm just going to kind of mirror what I want my tooltip to look like, so I'll just add a line break over there. So the next I'll just do GDP per capita, GDP per capita. Then with backticks I'll say GDP per capita. And again, I'm just kind of calling out my individual, column names. And I'll just add in a line break again. So we'll do the same thing for our life expectancy. I'll just lowercase it c, make it consistent. Life expectancy, and I'll just copy this over. And then I'll add in our population. So our population goes over here. And the population column does not require any backticks because there are no spaces in it. But one thing you may notice when we pulled in the data all the way up here is that we divided population by 1 million. So you can see like our population over here is in millions. So a nice way to represent that in our tooltip might be just to add a some additional text, mm, at the end, and then we'll just kind of close this out by separating each one of these arguments with a space. And I think I went a little too far there. Text is size equals population, and then we'll close it out. There we go. So now if I give all of this a run, there's one more thing we need to do. We need to say tooltip. Tooltip equals text. Give that a run. You can now see if I hover my mouse over each one of these points, it basically just mirrors what I put over here. So country, and then followed by a colon, and then the actual country column. So it's saying Slovenia. And then the same thing for GDP per capita, life expectancy, and population. So, I mean, that's a lot cleaner than what it was before. We're not, repeating things, and we have like full control over what goes into these this tooltip. So that is a nice little feature. So what else can we do? We can make this animated. So you'll notice I filtered the date to 2015, and it's really simple to add like an animation to the chart over here. The way we do that is we just say we get rid of that filter for one, but two, we would just add in an additional argument over here and just say frame, and we want to split it by year. We want to animate our chart by year. So we'll just add frame equals year, and that's not year by date. Our column is called date and not year with a lowercase d. So that's literally all we need to do to add this additional really cool, powerful element to it. So let's see what it looks like. So we're all the way in 1960. You can see that. So as we can scroll this little scroll bar over here, and we can see how the Preston curve evolves over time in current US dollars. Of course, that is a distinction that should be made. So you can, I guess, see how much people are making in today's dollars. So that's essentially what that represents. But the purchasing power of goods and services back then were different. So it is a little misleading to do that. Take the approach that I did. But it is cool, I guess, just for the sake of example, to show you how this animation works. And it is a little laggy, it seems like. I think when you put this in like an actual application, it is a little smoother. We can check that out later on, and I'm sure there are some functions we can use to control the actual animation itself. We're not going to go into all of those details right now, just for brevity's sake. We still have some more charts to get through. The next chart we're actually going to get through is a geographic chart. So we're going to take a world map and we're going to plot life expectancy at birth on it. And that's pretty much going to conclude the economic charting, and then from there we'll go into some financial charting. So looking forward to it, and let's get right into it. So geographic charts, and again this is with Plotly. So in this instance we're not going to use any ggplot, so it is possible to create a plot without ggplot. So Plotly is one instance where we can do that, and there is a little bit more legwork involved with doing something like this. So the way we would do that is just we have to just do a little initialization, a little setup. So I'll just create some objects over here called borders and map type. So let's first create our borders. So our borders are going to be a list, and the color is equal to 2RGB, which is like a Plotly conversion tool. I guess it's similar to the hex color picker. So if I just run 2RGB gray, you can see the output is just like a red, green, blue alpha representation of the colored gray in R. So that's what I'm going to do. I'm also going to add in the width. So these are the map borders, like the borders separating the countries. So that's basically what I'm setting up over here. Unfortunately, we can't just like wave a magic wand and have the map appear out of nowhere. So that's what we're kind of doing here as well with the map type. So we're going to say show frame equals false, and what the show frame argument does is basically it adds like a border around the map. We're just going to eliminate that border. I think it's show coastlines. Show coastlines equals true, so we just want the coastlines around the borders, each one of the different coasts. So the last thing is projection equals list, and type equals Mercator, which is just like the type of map projection that we will get. So just for context, I guess, map objects are formally referred to as chloropleths. That's chloropleth. So I guess that's just a fun fact. In Plotly, the way we do it is plot geo. So we're going to first define our data, and our data in this instance, we want to use life expectancy at birth. We'll just use a life expectancy data frame. In this instance, let's just filter down to our date equals to filter date equals to 2015. I'll just pick 2015 for fun. So data equals life expectancy. Okay, so that's the first argument. So the next argument is going to be to add a trace. Add trace. So for these map objects, we have to do a z-axis, not x or y. So we're going to add our z-axis to value. We're going to comma separate that, and you'll notice the syntax is a little different. Like I have these tildes before the column name. That's just kind of the convention of the Plotly kind of environment. I want my color as well to be value. So let's do that. And I want my colors to be equals to, so this is just going to be like the gradient. So we can do blues just to begin with. I'll show you like some different like coloring options that you can pick or whatever for that. So that's pretty much the color configuration in a nutshell. So text equals country, let's do that. And location. So locations, the chart needs to know like where to put like what. So locations, we're going to use an ISO 3C column ISO3C, and the ISO3C is just a 3-character country code and marker. So marker equals list, line equals our borders. So we're just going to take this borders and paste it right over there. Alright, so we're almost there. So similar to the way we have a color bar over here, we're going to just add a title in front of that color bar. So color bar title equals, this is our life expectancy. Let's just scroll up here. We can do life expectancy. What did we call it over here? Okay, we'll just use life expectancy at birth. Alright, we'll just use life expectancy. Whatever. Life expectancy. And then we'll just add a layout function. So this is our chart layout where we want to, it's kind of similar to labs, I guess, where you have title equals to, but layout we have title as well. So here we'll just do global life expectancy in 2015. And one last thing, we want to say geo equals our map type. So our geo equals map type. I mean, you could just pass all this through. I just find it a little cleaner to say, hey, I have this list called borders, and I'm going to use that to define my borders, and I have my map type, and this is what it is. So one just like peculiar thing with, Plotly Chloropleths is that they won't show up in our notebook. I don't know why that is, but you can see here if I try running it, I am getting this color gradient, which is a good sign, but I don't see anything else. That's just something you just have to know. It won't work directly in our notebooks, but what you can do, or even RStudio for that matter, what you can do is just go to your console and type in P, hit enter, and you'll get it over here on your viewer on the right. So the way you can actually see what's going on is you can click this show a new window, which will pop open your browser just as it has done over here, and ta-da, we have our map. I'm just going to ignore this little notification here. And you can see we have a really cool looking visualization of the world. So you can hover over every single country, you can zoom in, you can zoom out, you can see what's going on, you can click and drag. And what I really like about these Chloropleths and Plotly is that you can just scroll continuously for forever, and you'll always get the same rendering of the data, which is just a nice touch. I mean, it is a very nice touch. So I mean, yeah, there you have it. That's pretty much that. Let me just maybe show you some other color combinations. You can do greens, and if we just store that under P, hit P in our console and open it up in our viewer, our new window, and you'll see this opens things up in a browser. You can see that, I mean, here it is. So instead of blues, which we had over here, we have greens over here. So yeah, there you go. So that's pretty much all I wanted to show you with economic data. Let me know what you think. If you want to see anything else, if you have questions about any of the economic charts that we went through, yeah, just let me know, and I'll be happy to troubleshoot you if you get the stock or anything. If there's any specific chart you want to see, just let me know. I might put together like a mini clip of like 5 minutes just going through the chart structure and everything. But that pretty much concludes the economic charts. So let's get right into the financial charts. So this is kind of the tail end of our video here, financial charts. And I'll just maybe say like OHLC, open, high, low, close. So what we'll do is we'll first use the quantmod package to pull in some stock data. Quantmod get symbols. And then I don't know what ticker do we want to use today. We can do Tesla, we can do Apple, we can do, let's use like AMD for example. We can do AMD. I know that's a crowd favorite. We'll do AMD, and I just want to show you how ridiculously simple it is to create a nice financial chart in highcharter, HChart, AMD. So if I give all of this just a quick run, 2 lines to pull the data and to chart the data. I just hit the play button on our notebook, and look at that. Isn't that just awesome? I mean, we have this really cool open, high, low, close. We have this slider over here. We can like do a year to date, 12-month period. So I mean, it is pretty cool if you ask me, how simple it was to do this. But let's say we want to you know, have greater control over this chart. So I mean, there are like multiple ways we can go about this. I'll just basically explain the problem we want to do first. So what we want to do is we want to take this open, high, low, close and just kind of condense it into like maybe 1/3 of the area up over here. So just like add it and just put it into like a little box over here, and then we'll throw the volume chart right over there into like the second third. And then we'll add some additional indicator. In this instance, we'll use RSI, which is the relative strength index, to just add like another technical indicator, which some use as you know, an indication to see whether an equity or an instrument, whatever financial instrument you're looking at, is overbought or oversold. It could be used in like you know, some algorithmic trading strategies and so forth. So we'll put together this open, high, low, close, followed by volume, followed by RSI with some open, high, low, with some you know, with some overbought and oversold lines. So we're going to start off by using highchart, so highchart function. And one thing before I do that, I just want to show you the lack of compatibility as well in highcharter with our markdown, or these are our notebooks. So if I just run this really quick, it does take a bit to load, but you can see there's this little sliver where the chart should be, and if I scroll through this, you might actually be able to see the chart, but it's not rendering on the whole thing. I think that's a bit of a bug. But the way we can work around that bug is just by, you know, just saving down P and running P, and you'll see in our viewer over here on the right, I'm actually going to move my face over here, just maybe I'll scoot it up on the top right over there, so I can size this up. So we'll be using this as our window, and just kind of do one of those. Maybe I'll put my face right down over there. Maybe over here, so I'm looking at the chart. Alright, so here we're going to do type equals stock. And then, so now we need to do some setup. It's called HC_Y axis multiples, and then Y axis. So I'll just start typing create Y axis. So we're going to start out with the number of axes, and then we'll say our height is equal to 2 by 1 by 1. And then turn opposite equals true. Alright, so from there, that's kind of our setup, and what we did was the partitioning. So the partitioning that I was talking about earlier, with adding these different rows where we will just kind of like strap our graphical objects, like onto each one of those rows explicitly. So we're going to do HC underscore add series, and then I'll just start off with AMD. So if I just give this a quick run, I'll maybe just add in a name equals AMD, and I'll just call it P. Let's just call it P2 because we already have P. And what I'll do is I'll just run P2 down there on my global environment. You can see it's kind of floating over here. So there it is. You can see that there's some white space over here now. We're going to fill this white space up. So let's do that right now. So the way we do that is we're going to first do another HC add series, so we can just copy and paste that down below. Instead of AMD, we're going to do AMD.volume, and the reason we do that is just because AMD.volume is how, I don't know if we can see it here. I wonder if I do one of those. So here, let me just show you this instead. Let's just look at AMD for a second, how it gets pulled in from quantmod. So I just pulled the first like 5 or whatever rows in. So you can see we have open, high, low, close, and then volume. So that's why I'm saying AMD $ AMD volume. So if I just put AMD $ volume with AMD dot volume, you'll see I just get that column. So there you have it, and I'll just call it name equals volume because we're looking at a volume. So I also want to define the axis that it falls on. So y-axis equals 1 now. So if I do that, and let's also, you know, make the color a different color. I'm going to jump over here to my hex color picker. I'm just going to pick an orange. I kind of like how that looks with like a blue and orange. Kind of complement each other. So just, you can use hex codes. So color equals this hex code that I just copied and pasted. So do one of those, and if I just run P2 again, you'll now see over here on my viewer, this little fella should pop up. I want to look at volume as like columns, so let's do type equals column. I think it's column, it's not columns. Yeah, it's column. So let's do that one more time. P2, hit enter. And looks like there we go. So that worked just fine. So now we have some volume bars and we have some open, high, low, close. So let's kind of wrap this thing up. Let's do our RSI. So the way we calculate RSI, the relative strength index, is by using the TTR package, RSI. So that's basically, I mean, all we do, and it's just a kind of measurement of, or indication of whether or not a you know, equity or derivative or bond or foreign exchange or whatever is overbought or oversold. One more thing is we'll do the RSI and the closing price. So quantmod, I think that's where it comes from, has this CL function. So it's just extract the column A and blah blah blah. This is basically, you're just getting the closing price column from AMD. So if I just look at that really quick, see what that looks like, you can see I have AMD close. So we're just going to pass this RSI through AMD close, or AMD close through RSI. So let me just copy and paste that. I'll just type it whatever. So and I'll just do head, and head just returns like the first like 5, 10 values or whatever. Get some NAs because I'll just show you like 30 observations. So you can see, there we go, because it's taking some historic values, but you can't go back 14 observations when you only have 1 observation before it or 0 observations before it. So that's why we have those NAs. So, okay, so let's do these RSI series. So HC underscore add series, and you may have realized this by now, but this is not ggplot either. This is just like native highcharter functions in R. So we're going to start off by doing just copying this right in there. Call it RSI. We'll put on the second axis, so y-axis equals 2. So let's just make this color black. Alright, so we don't need to worry about type column. Alright, so let's see what that looks like, P2. So P2, just give that a quick run. It'll pop up over here on the right. Just doing some thinking. So there we go. So we now have our RSI down on the third item below. Let's just kind of wrap this thing up by putting just some levels of relative overboughtness, I don't know if that's a word, or oversoldiness, just to see whether something is overbought or oversold. So let's make the colors for being oversold maybe green. We can make the colors for overbought red. So we need to change this up. So I'll just kind of just make this oversold and make this overbought. Alright, now you can, I mean, this is totally preferential, so some people will pick 30, some people will pick 20 for being oversold, some people will pick 75, some people will pick 70 or 80 for being overbought. It all depends on the strategy, and just this one number will not ever be a good way for you to decide whether or not to buy an equity or whatever financial instrument. Never use one number as this kind of like holy grail to determine whether or not you should enter a position. It should be a combination of, you know, fundamental research, quantitative research, and, you know, maybe just a, you know, timing is key. So what's the broader like macro trend with the market? So I mean, there are so many different factors going into whether or not you should buy or sell an equity, and this RSI is maybe a technical indicator, but it should not be treated as a way for you to enter into a position just because it tells you some relative level of being overbought or oversold. So disclaimer aside, let's get into it. So we'll create a XTS object. We will say rep, which is like a repeat number in R, like base R, and we'll repeat n row times n row AMD. So let's just unpack that for a sec. So we have n row, which just says, okay, AMD has 2,816 rows. If we repeat the number 30 that many times, this is what we get. We just get a bunch of 30s, and that's the effect we're going for. We just want a straight line just going right through that. So we can see whenever we've kind of passed that threshold. So the next thing we want to do is we just want to create our index to AMD. Okay. So our index basically just shows all of these. So these are just like the dates from the AMD object. So when you pull in the data from quantmod, the index will be equal to your dates. So I'm just going to delete that because it's going to actually be easier for us just to copy and paste and just selectively change some of this information over. Overbought. Looks like we don't need this anymore, and we want to make this red. So let's just double check the code. It looks like everything's good, so I'm just going to give this a run. P2 over here. So I'm going to see what P2 looks like. Hopefully it came out what I had expected it to kind of come out to, and I think it should. So let's let this do some thinking, and there we have it. So let's kind of blow this up. Let's look at it in like a bigger, the window view. So here we go. So we have pretty nice. I'm gonna move my head here for a sec. Not the window, but my head. I'll just put it right over here. That's kind of awkward. I'll just kind of scoop myself. I don't know where to put myself. Alright, let's just put me right there. So you can see we have like the ability to look at individual months. We have the ability to use this dragger to just look at different points in time. This RSI just kind of shows like the level of being overbought or oversold. There is some like rounding related stuff going on. I don't know if you notice like this hover tooltip text is not rounding RSI. You can probably configure that in the options. If we look at this like level here, if you had bought when RSI was at 12 and you just held until now or whenever this goes to March 5th, it looks like you'd have a pretty nice return there. So but at the same time, RSI was pretty, below the overbought portion here, and if you had bought over here and kind of panic sold it at this level, it went from what? Let's see, $6.80 or so at its high, and when RSI was at about 24, it then dropped to like $2. So of course, time horizons are important, because if you had bought and then sold, or you're still holding to this day, you would have a pretty, you would have doubled your money. But if you had used this RSI as like a short-term guide, and then you're like, oh no, it told me the wrong thing, because it's kind of lost half its value. It's like $3 over here. You may have panic sold, losing a lot of opportunity. So that's why you shouldn't use one number just as indication of entering into a position or not. So next video, I'll go over like actual algorithmic trading, creating signals and combining signals together. So you can add a Bollinger Band, a long-term average, a short-term average, plus RSI, and create like a series of different signals to then implement into like an algorithmic trading strategy. I know one of you asked to see this in Interactive Brokers, so I'll use Interactive Brokers paper account, fake money account, to actually set up an algorithmic trading bot, I guess, and we'll kind of play around with that. So just to give a recap, and if you get stuck with any of this stuff, just shoot me a message. I'll be glad to help. I would appreciate if you could like, comment, and subscribe. If you have any questions, or if you want to follow along with these future videos, please by all means do so. So let's just do a recap. We did some economic charting. We did quite a lot in this hour. So we did a line chart. We created some nice formats. We did this histogram. We just kind of played around with the colors and showed how adding like your borders and colors can actually make your chart a little more accurate. I don't think, did I show you the describe function in psych package? I don't think I did. Let me just quickly do that. So looking at this, you can see there's negative skewness, and skewness is just the measurement of asymmetry between your left and right tail. So we can just validate whether or not that skewness is negative by using the describe function within psych. I can't remember what this data frame object was, so I'll just say describe life expectancy and value. So you can see the skewness is negative, and the reason I wanted to show you psych was because of this function called describe. It is great. It has all of this summary statistics. You have skew, kurtosis, standard error. You have like a trim for outlier, median or mean. I can't remember if this is like a mean or median. I have to look into the documentation, but yeah, it's just a little nicer than whatever we had the summary function in base R. So that's basically what we went over there. We created this really cool animated interactive visualization. It's a very buzzwordy chart. So if you want to wow people with your ability to make interactive visualizations that come to life, this is how you do it. You start in 2010 and hit play and show how this data kind of evolves over time. We then went into some geographic charts. So let me just pop open my browser here. So these are the geographic charts we went through using Plotly. We used Plotly's like native charting function instead of ggplot to make this happen. We changed the color scheme from blues to greens, and finally we created this nice little financial chart using quantmod and highcharter to make it happen. So we're going to leave it at that. If you have any questions, comments, please let me know. Have a great day, and I'm glad we got through all of this. So hope you enjoyed. All right, bye.